Okay, good morning. So I think I will keep today's lesson very short because actually we did everything we need for this double and half angle formulas. I don't know, in the book there is a distinction between double and half angle formulas, but last time I tried to convince you that actually they are the same formulas. Yes. So if I want to have a short recap, so if you remember we had some addition and subtraction formulas, yes? So we learned that sine of uh, alpha plus or minus beta is equal to sine of alpha cosine of beta plus or minus sine of beta cosine of alpha. So I'm just using alpha beta instead of u and v because you complained that it's not easy to recognize the difference between u and v in handwriting. So that's the same formula, it's not something strange. So that is the addition and subtraction formula for sine. And then we had two formulas, alpha plus and minus beta for cosine. And then do you remember something that we will have cosine of alpha times cosine of beta? But if the sign is addition here, so plus, you should put a minus. If the sign is negative, you need to put a plus there. And then you have sine alpha, sine beta. Yes? So that was the addition and subtraction formulas. And then, for example, for the first one, a natural question is that, can I write sine of 2 theta? Do I have any formula? So this is called the double angle formula in the book. So, and the reason is clear. You have an angle, you double it, and then you want to take the sine of that angle. So is there any formula for that? If you remember, we learned that instead of 2 theta, I can imagine that this is theta plus theta. And then I can use this formula with the plus sign and giving the role of theta to this alpha and the role of this theta to this beta. And then what happens? It becomes the sine of the first one, sine of the second, cosine of the second one. And then plus sine of the second one, which is again theta, multiplied by the cosine of the first one, which is theta. And then you see that exactly the same combination appears. So you are adding the same expression 2 times. So this is why it becomes 2 sine theta cosine theta. So then we discovered the formula. So it becomes sine of 2 theta is equal to 2 sine theta times cosine theta. So it is extremely important to understand, and I told you that usually in most of the books they do not put these pair of brackets around the 2 theta. So you shouldn't read it as sine 2 times theta. If you want, so you need to understand that this 2 theta is in pair brackets. And then what happens, this formula tells you that in principle you can pull these 2 out, but the price that you have to pay is to multiply by an extra cosine. So this is not the case that you just simply pull 2 out without any changes. Yes, just if you want to understand. So this is the formula. This is the double angle formula for sine. But as I told you, you need to understand it in this way. So this tells you that if you have sine of a box, anything inside the box, yes, what appears here and there is this box divided by 2. So here I have started with 2 times theta. So here I have written theta, which is half of this angle. Okay, so if I give you sine of any box, what you realize is that this is 2 times sine of that is inside the box divided by 2 multiplied by cosine of the box divided by 2. And the book is referring to this as half angle formula, but they are not different formulas. Is that understandable? So it's actually they are the same formulas. So in the book you see that they have written sine of x is equal to 2 times sine of x over 2 cosine x over 2 under the section of half angle formulas. And they have written something similar to this under the section of double angle formula, but they are actually indeed the same thing. Yes? So very important to realize that when you have this formula, so for example, if I ask you, can I write something for sine of x over 2, the answer is yes. If I want to use this formula, what should I write? I should write 2 times sine of this angle, which appears, no, sorry, this angle divided by 2. But this is x over 2. When I divide it by an extra 2, it becomes x over 4, yes? And then I multiply it by cosine x to the power x over 4. So that is also an immediate consequence of this formula. So you should be able to play around with these angles, half angles. So that's very simple, yes? For example, can I write something for sine 8x? Let us try to decompose it as much as possible. So what can I write? For example, I can write 2 sine what? 4x multiplied by cosine 4x. If I want to, I can still continue, because sine 4x can be written as what? 2 times sine what? 2x times cosine 2x. And then of course I have this cosine 4x at the end, yes? Then, for example, 2 times 2 becomes 4. Then you have sine 2x, I don't know, cosine 2x, and then you have cosine 4x. Yes? So again, if you want to, you can break this again. So it gives you a factor of 2. This becomes 8. And then you have sine x, cosine 2x, cosine 4x. Yes, so you see that you can discover a lot of relations yourself. Yeah? So this is important to remember. Okay, another thing that is very important to remember is this combination in trigonometry is famous. It should be famous for you. Okay, so whenever you see this combination, this should draw your attention to this point. So you remember, there are some combinations that are famous. Yes, so far we learned that sine squared of an angle, so let me write a box here. Sine squared of any angle plus cosine squared of that angle. This is one of those expressions that should be familiar to you. Another combination that should be familiar to you now according to this new lesson is sine of an angle multiplied by cosine of that angle. So this combination, so the sum of the squares should be famous to you. This combination that I am multiplying the sine and cosine of the same angle, that is also famous. Can you write something for the lower one for me? What can I write, for example, if this appears, if I want to, what can I write? So here, sine theta, cosine theta, if I want to write something for sine theta, cosine theta, what can I write? Sine theta, cosine theta is what? Is 1 over 2 sine 2 theta. Yes? So this combination is famous in trigonometry. So sine of a box multiplied by cosine of the same box, whatever inside that, it becomes 1 over 2 sine of 2 box. Of course, you will not see these formulas repeated over and over again. You have just one single formula, but you yourself can conclude all these things that I have written on the board just from the same formula. Yes? But you need to learn how to do that. Is that understandable? So, one famous combination, of course the answer to this is very clear. What is that? 1. And then this is something, of course there are 2 consequences of these, yes? So if you want to, you can write, this is also important to write it down here. Sine squared theta, sine squared box is 1 minus cosine squared box. Or if you want to, you can write cosine squared of a box is equal to 1 minus sine squared of the box. Yes? So if 1 minus cosine squared appears, that should be famous to you. 1 minus sine squared appears, that should be famous to you. So these are the formulas which are a consequence of this head-on formula, and sine cosine should also be famous to you. Questions? Okay. Let me give you an example before. I don't remember if I did this example similar to this before. Yes? Questions?
On the test,
Yes?
when we're supposed to find, or we want to find sine squared,
Yes?
do we have to write the whole formula, or is it okay if we just write sine squared is equal to minus?
No, for this famous one, I am not that sensitive that you describe everything. So whenever you start, for example, if you start from here, that's okay. Yes? Because these are so famous, because if you want to explain everything, that would be a mess actually. Okay, so let me write an example. I don't remember if I did it before or not, but we can just try to do. By the way, I can choose. The example in the book is good actually. So determine the exact value of sine 2, let me write theta, it's more clear. Sine 2 theta if sine theta is 0.6 and theta is an acute angle. I would consider this also important. So when I write something is important, it means that probably I will ask a question regarding this in the exam. And not exact question, but the idea of the question. Actually, this book is very good. The examples solved in the body of the text is actually good examples. So yeah, make sure that you really understand all those examples which is already solved in the book. Okay? So determine the exact value of sine 2 theta if sine theta is given to be 0.6 exactly, and we know that theta is an acute angle. Okay, so what is the point of giving you that theta is an acute angle? It means that angle is between 0 and 90 degrees, so it is in the first quadrant, yes? So what you need to do, I changed my color for the solution. So what happens, you know that this is sine of 2 theta. Okay, then what happens, we have a formula for that. This is sine 2 theta, 2 times sine theta cosine theta. In order to be able to answer this, I have to know about sine and cosine. For sine, I do not have any problems. I just have it. But for cosine, I need to calculate. But this is also a typical problem. So to find cosine from sine, it should be simple for you. So for example, let me just start from this combination. Of course, you can always, let me start in my solution from here. But if you write in the exam using one of them, that's okay. So sine theta squared plus cosine theta squared is equal to 1. And sine is given to be 0.6 to the power of 2 plus cosine squared theta is equal to 1. And then what you get is that cosine squared theta is equal to 1 minus 0.36, which is 0.64. And then cosine theta becomes what? Plus or minus 0.8. So this is why I'm sensitive to that. You show that this is plus and minus, and then tell me that why you are choosing the plus 1 or the minus 1. So that is really important in the problem. So theta is an acute angle. This implies that cosine theta is positive 0.8. Yes? So I think I translated. They have written it is in the second quadrant. Anyway, this is not exactly the same question in the book. Okay, I have written it as an acute angle. So it means that it is in the first quadrant. Yes? Okay, anyway, so what you get is that the question mark that you are looking for is 2 times. Let me just write this cross because it would be very similar to this decimal point. So 2 cross for product, and then I have 0.6, then cross 0.8. So if I calculate this, it becomes 0.96. So that would be the exact value of this expression. This is a simple but a very typical example. So one information is given to you, another sine or cosine is wanted, so or tangent. You should be able to calculate these things easily. Any questions? Okay, now let us just review a little bit about formulas for cosine. For cosine, we have three alternatives. Of course, they are the same formulas written in different ways. So, okay, so let me write, so here famous combinations. Okay, so one famous combination is sine squared box plus cosine squared box is equal to 1. So you can immediately write that this is also a famous combination. The answer is cosine squared. So this is also a famous one, is equal to sine squared. Okay, we just learned that sine theta, cosine theta is also a nice combination to remember. This becomes 1 over 2 sine of 2 theta. Okay, so I want to add to this list some more. So here we have cosine alpha plus beta. So in this formula, let us take alpha to be equal to beta to be equal to theta and plug that in that formula with addition. So this becomes cosine of theta plus theta. On the right hand side you will have cosine of theta theta. So it becomes cosine theta times cosine theta. And then you see that if I choose the addition here, I have to choose the negative sign here. So then it becomes negative sine theta. And then this is interesting, yeah? You see the same combination that you see in the Etan formula appears here, but the only difference is that you have a negative sign in between, yes? So this becomes cosine squared theta minus sine squared theta. Okay, so then this is your formula. Cosine 2 theta is equal to cosine squared theta minus sine squared theta. Okay, so let me add this famous combination here. So this combination has also an alternative, but the answer is quite different. Here in this combination, it doesn't matter if you start with sine or cosine, because that's addition. But here it's crucial to start with cosine squared, not sine squared. So cosine squared minus sine squared is also a famous combination, and the answer is cosine of the double of that box. Okay, so compare these two. So this is important to compare these two. The answers are totally different. Okay, and then you saw that this is, even though this is one way of writing this is expressing cosine 2 theta in terms of sine and cosine. But of course, you can use one of these combinations, each one of these combinations, to write this in a different way. For example, instead of cosine squared, I can write 1 minus sine squared, and I have another minus sine squared. And then it becomes 1 minus 2 sine squared. Or you can keep cosine squared, and then what? You write minus 1 minus cosine squared. But then minus cosine becomes positive cosine, so it becomes 2 cosine squared theta minus 1. So this is why usually you see 3 formulas, 3 alternatives. I cannot say there are 3 different formulas. So there are 3 alternative ways to write cosine 2 theta. Okay? So all of them is necessary to understand at least. Even if you forget, I don't know, I think in all of them are given in the formula sheet, but might be the case that you are given only this one. So you need to understand how to find the other ones. So the formulas for cosine squared, cosine of 2 theta is 3 alternatives that I write here. This we already talked, so that's also good to know. Okay, so let me add immediately one question from the book again. Okay, so here I choose this problem from the book. That's also a good problem. So here you are supposed to determine the exact value of cosine 2x if it is mentioned that if sine x is square root of 3 divided by 3 and x is an acute angle. So that was, I was confused with this. So x is an acute angle. So hopefully, what I want you to, so that's also I would write important. So let us have one agreement. All the questions that are solved in the body of the text, I will call them important, okay? So all of them are important actually. So because I think that they have chosen very nice examples when they want to solve the problems in the book itself. So determine the exact value of cosine 2 of x if sine x is, by the way, I want you to see that, could you connect this problem to the material that we studied today? Because, of course, it is clear I am teaching you double and half angle formulas, so every example that I am presenting is somehow related to that. But assume that 2 months, I don't know, 7 weeks, 8 weeks has passed, and then you reach to the exam, you yourself need to understand which question is related to which topic. Here it is clear. That is a downside of teaching session by session. Of course, I cannot do anything. But this is important. Assume that 2 months from now you get this question and your trigonometry knowledge is more broad because you have learned a lot of things. So you yourself need to understand I should connect this problem to the material that I am covering today. So this is really important. Sometimes I didn't remember to emphasize on that. Can you understand that? This is related to the problem that we are talking today. How, for example, what's the indication? Yeah, you are talking about cosine of 2x. Somehow, at least this is very clear that that's a double angle formula. Okay, then you have 3 alternatives here. If you want to solve this problem, in principle, you can use 3 alternatives here, whatever you like to, but which one is more suitable in this context? Which one? The first, the second, or the third? The second. Yes, because this gives you cosine immediately in terms of sine. You don't need to calculate something more. Yes? So if you want to calculate using this, it is possible, but you have to first find sine. You have to first find cosine so that you have cosine and sine, use this formula. So it is clear that if you choose the right formula, life would be easier for you. So I would write cosine 2x is equal to 1 minus 2 sine squared. And then you see that this would be not relevant. This piece of information is actually not needed here, unless you insist to solve the problem using this or that. So choosing the right formula is really good. So it becomes 1 minus 2 times square root of 3 divided by 3 to the power of 2. So let me just put cross here. Okay, so then this becomes 1 minus 2 cross. This becomes 3. This becomes 9. and then this becomes a third, so it becomes 2/3, and then if you calculate, it becomes 1/3. So the answer is immediately clear, and that's 1/3. Yes? Now, I want to pay attention, draw your attention to a very important point. So this you will need a lot in the university. So let me try to work with these two alternatives of cosine to see what you get, and I want to put them actually in the famous combinations. Okay, so here, for example, let us start with this. Cosine 2x, cosine 2 theta is given to be 2 cosine squared theta minus 1. Yes? What can I do? I can move 1 to the left, so it becomes 1 plus cosine 2 theta is 2 cosine squared theta. Yes? So let me put this combination in the famous, in this box. Yeah, I really want you to write them somewhere. It would be useful for even for your future when you study mathematics at university if you want to do that. Okay, so a famous combination is 1 plus cosine of a box. This is a famous combination. So don't get confused here. So this is 1 minus cosine squared, but this is just 1 plus cosine theta. So you need to remember that's also somehow a famous combination in trigonometry. So what the answer is 2 cosine squared of what? Can you tell me what should I write according to the formula you see there? So you see 1 plus cosine 2 theta is 2 times cosine squared theta. Now instead of 2 theta, I am putting a box here. So what should I put here? Box divided by 2. Yes? So this is a famous combination. Read it the other way around, that's also a famous combination. So I divide this by 2, I will write it here. I don't want you to confuse you. All of them are the same thing, but the reason that I am writing it is that now I have an alternative for cosine squared theta. So you see, if I change theta to if I change the box to 2 box, this becomes 1 plus cosine of 2 box, then 2 box divided by 2 becomes box. So you see, for cosine squared box, there are 2 famous combinations. All of them are actually important. One of them is 1 minus sine squared. One of them is 1/2 1 plus cosine of double angle. Okay? So I don't want you to memorize them, but these were very famous combinations. So let us work with the other one. So cosine 2 theta is 1 minus 2 sine squared theta. So what can you do? I can move this to I can move this 2 sine squared theta to the left, and I move cosine 2 theta to the right. Yes, so that 1 minus is also a famous combination. 1 plus cosine was a famous combination. 1 minus cosine is also a famous combination. So 1 minus cosine, this is playing the role of your box. So here it is box divided by 2. So then it becomes 2 sine squared box divided by 2. So especially these two will be very important. So you see 1 plus cosine, 1 minus cosine. For 1 plus cosine, you can write 2 cosine squared box divided by 2. For 1 minus cosine, you can write 2 sine squared box over 2. So all of them are the same formula. I am writing them in different ways. And then finally, you will get this combination from here. Sine squared of the box is 1/2 1 minus cosine 2 theta. So you see, I have 2 famous combinations for sine squared, this one and that one. But here, the angles are the same. In this combination, one angle is 2 times larger than the other angle. And then you remember these combinations are also famous. 1 plus cosine theta is this, and 1 minus cosine theta is this. Okay, let me give you an example here. So do you remember we actually calculated cosine of 15 degrees in one of the previous sessions. So here let me ask you to do this again. So determine, so let me emphasize how to do it. Oh, okay, so determine the exact value of cosine 15 degrees. Number one, using subtraction formulas. Using a subtraction formula. Two, using double angle formula. Number three, compare your, okay, so we want to compare them later, okay? This part I remember, I did it in one of the previous sessions, so I want to calculate the exact value of cosine of 15 degrees using a subtraction formula. So let me just clean this here. Okay, so do you remember, can you help me to solve the first one? This is just a repetition of what we learned before. So if I want to use a subtraction formula for calculating cosine of 15 degrees, so what can I do? Of course, when I say what can I do, I always mean that you have that long table in front of you. That would be in the formula sheet. So you know that the famous angles there are, for example, 30, 45, 60, etc., etc. So how can I answer this question? Yes?
Cosine 60 minus 45.
Yeah, this is one alternative. Another one is 45 minus 30 degrees. It doesn't matter. So let us choose yours. So number one, so you say to yourself that, okay, cosine 15 degrees, of course I can write 15 degrees in infinitely many ways, but all of them are useless except these two pairs, yes? Because I know information about. So you said 60 minus 40, if I remember correctly. So let me write as yours, okay? So everyone agrees that there is no difference between 60 degrees minus 45 and 15. They are the same. And now we have the addition formula. So the addition formula is cosine of the first one multiplied by cosine of the second one plus sine of the first one times sine of the second. Yes? And then if you look, if you refer to the table, cosine of 60 degrees is 1 over 2. The other one is the square root of 2 over 2. Sine of 60 degrees is a square root of 3 over 2. And then a square root of 2 over 2, yes? And then this becomes square root of 2 divided by 4 plus square root of 6 divided by 4. So the exact value we get from this formula is square root of 2 plus square root of 6 divided by 4. That's the exact value for cosine. Cosine of 15 degrees. So let me give you a hint for the second one. One of the four formulas you see here on the board is useful for the second one. Which one? Which combination is useful for the second method? Actually, all of them are they are pairwise the same. These two formulas are the same. These two formulas are the same. One of them is a consequence of the other one. But which one in this form is more suitable to use for calculating cosine of 15 degrees? Yes?
Maybe the one excluding sine, where it's only
So no, here, from here.
2 cosine theta minus 1, maybe.
Yes, yes. So here you are talking
Yeah,
about
I'm using that one.
this one. Yes, that's correct. So that, but I want to use this alternative. Of course, you might be right. I want you to know these combinations. Okay, that's up to you, but they are not in the formula sheet. Let me use what is in the formula sheet. Okay, so I will use cosine 2 theta with its third alternative here. So I would write cosine 2 theta is equal to 2 cosine square theta minus 1. This you have, I think, in the formula sheet. At least this is in the box in your book. And I think these orange parts are actually in the formula sheet as well. By the way, I will upload the formula sheet for you so that you can make sure that which ones you need to memorize. Okay, so then I choose theta equal to 15 degrees. Yes, so here I put, this is valid for all choices of theta, but in this context, I want to find cosine 15 degrees. So let me choose, choose theta to be equal to 15 degrees. Then, what can I have here? It becomes cosine 2 times 15 degrees is equal to 2 cosine squared 15 degrees minus 1. Yes? Let me write this a little bit properly here. So here you need to calculate cosine 15. Square it. Multiply it by 2. Whatever you get, you subtract 1 from it. Yes? Okay, and then because we don't need this anymore, so let me just remove that. So 2 times 15, we know about it. It is 30 degrees. And then this becomes 2 cosine squared 15 degrees minus 1. But if you refer to that famous table that you have, cosine of 30 degrees is a square root of 3 over 2. So then you just write square root of 3 over 2 instead. It becomes equal to 2 cosine squared 15 minus 1. Of course, I still believe this method is superior to this one, but I want to teach you something. This is the reason that I am doing it in this way. First of all, you can see that this is also doable. My unknown is this. This is my question mark. So I need to find this question mark. So what I have to do, I move 1 to the other side. So it becomes 1 plus square root of 3 divided by 2. It's equal to 2 cosine squared 15. So let me take the common denominator. It becomes 2 plus square root of 3 divided by 2 is equal to 2 cosine squared 15. If you don't understand something, please let me know. I forgot to put the degree sign here. And then I divide by 2. So this becomes 2 plus square root of 3 divided by 4. I divide both sides by 2. It becomes cosine squared 15 degrees. But I have to take the square root, but I need to remember to put plus and minus. Whenever you want to find an unknown and you are taking the square root, you have to remember to put plus and minus. But which one is acceptable? Plus 1 or negative 1? Be careful, you have to show this respect that you are putting plus and minus and then discuss why one of them is acceptable, not the other one. So, is the positive one acceptable or the negative one and why? Yes?
The 15 degrees is an acute angle, so it should be in the first part.
But, so it should be positive, yes? So it becomes this one. So let me just remove them. Okay, so what happens, cosine 15 degrees becomes positive. And if you don't mind, let me just break this square root sign into 2 parts. the square root of the numerator, square root of the denominator. But the square root of the denominator is simple, it's 2. Yes? Okay, now apparently the answers are different. Yes? So the cosine we got from that formula is that number. The cosine we get from this formula is this number. If you really trust what you have written on the board, then you have a nice result. This number is equal to that number. Yes? And that is indeed the case. Both of them are correct. So if you write this, that's correct. If you write that, of course, which one is superior here? The first one, because it was very short. But that's also a very good way to do these things I want you to learn. But let me do some arithmetic. Can you tell me why these two numbers are equal? Yes? Hmm? Okay, so let me pause the video for 2 or 3 minutes to see that if you can convince yourself that these two numbers are the same. You are in the 3rd grade, so you should be able to do that, yes? Without calculator, of course. If you want to do it using calculator, what do you do? Yes? The good way, especially if you have not a very precise calculator, is to write the difference of these two numbers and then press the execute button. You should get 0. It's easier than calculating and comparing them, yes? Okay, so yeah, you can do that, but I want you to convince yourself that these two numbers are the same. By the way, if this is not the same, so we have to forget mathematics, yes? Because this would be an internal inconsistency. And mathematics is only, it cannot tolerate even one single inconsistency. The whole thing will collapse, okay? So this is very important. If you want to get rid of mathematics, you can spend your life to find inconsistencies there. Yes? So it's very important to remember this trick. So if you have a complicated third expression, you want to convince yourself that that third expression is related to the other one, they are equal. Of course, if you want to compare them directly, it would be hard because of these external thirds and things like that. But if you square one of them and square the other one and compare the squares, if it happens that the square of those numbers are equal, and if it is guaranteed that those numbers are both either positive or both negative, then you can conclude that they are also the same. What I'm saying is that this is a very trivial fact. If I tell you that x squared is equal to y squared, and if I tell you that x and y are both positive, so what is the only conclusion that you can make about x and y? What is that? If I tell you that two numbers x and y have this property that the squares are the same and both of them are positive, what is the immediate consequence of these two? Yes? They are equal. So this is something, sometimes proving equality of numbers is hard, exactly like this case. This is a number, I want to show that this number is equal to that number. It seems to be hard, but if I square them, it would be easier. Why? First of all, if I square this nasty number, then this big square root sign will go away. And then it becomes easier to compare. So remember this as a tool in your toolbox. So if you want to solve those problems. So I will pause the video again. By this guide, you should be able to solve it. And if you solve it, if you're a volunteer, you can come here and show it to everyone. So if you don't mind, let me solve this problem myself for you. And then I will write one example here. Then I don't solve it. You can work on that problem. I have already posted what I suppose, what you're supposed to do, okay? So you can start working on those problems. These are very important. The question, the lesson is very short in the book because that's just the formula, but you need to train your brain so that you can detect these patterns as immediately as possible so that you can use them. Okay? So here, let me just see what can we do here. So let me consider this number to be x. And then let us consider this number to be y. My goal is to show that hopefully x is equal to y. And of course, you don't need to try hard. It is immediately clear that x and y are both positive. So instead of showing that x is equal to y, I show that x squared is equal to y squared. Okay, so let us do that. So you can help me to do this. What is x squared? I have a fraction, the denominator is 2, the numerator is this compound surd. So if I square it, what happens for the denominator is simple. What happens for the numerator? It becomes 2. Yes, the bigger one will go away. So let us keep it for the time being like this. I cannot probably proceed that much. Let me calculate y squared. So y squared, the denominator of y squared is clear, which is 16, but the numerator becomes this. Yes? But here, what can I write? I have to use the squaring pattern. So it becomes the first one to power 2 plus 2 times the first one times the second one plus the second one to power 2 and then divided by 16. 2 plus 6 is 8 plus, what happens here? It is 2 square root of 12 divided by 16. Yes? I can factor a 2 out here. It becomes 4 plus square root of 12 divided by 16. These 2 and this 16 are gone, so I get this. But do you think that this is still, is it clear that this is equal to that? I have to do something more. Yes? What should I do now? 4 plus square root of 12 divided by 8, but I'm supposed to get 2 plus square root of 3 divided by 4. Yes, Dennis? Yes, exactly. Square root of 12 can be visualized in this way. And then this becomes a square root of 4 times square root of 3, which becomes 2 square root of 3. So then I continue and I will write 4 plus 2 square root of 3 divided by 8. And then I take the 2 out, so it becomes 2 plus a square root of 3 divided by 8. Then it becomes 2 plus a square root of 3 divided by 4. So you need to understand the logic. The logic was to compare x squared and y squared. You see that x squared and y squared are exactly the same on the one hand. On the other hand, you know that both x and y are positive. So there is no other chance except that x is equal to y. Yes? So this is the reason that x is equal to y. Okay. I just write an example. The lesson is finished. You have nearly 20 minutes. You can work on yourself and really do that. Don't waste your time. This course will be a heavy course, so don't try to waste any time here. The recommendation is already updated on Google Classroom. So let me write it as an exercise, not an example. So exercise. Let theta be an acute angle such that tangent of theta divided by 2 is 3/4. Determine sine theta, determine the exact values of sine theta and cosine theta. Okay, so I would recommend you to start with the problems in the book. When you are getting more experience, then you can come back to this exercise, okay? Any questions? Okay, thank you. So I will stop this recording. But I think you have around 15 minutes at least, so it is better not to waste the time. Thank you.